A times B equals A times C. So down at the bottom, there are two examples of distributive property down at the bottom, 1 through 14. Can anybody tell me one of them that represents distributive property?
6.
6. Number 6. So where it says 6, we're going to put distributive property. What other one? There's one more.
14.
14 is also distributive property. So this is really like a review of Algebra 1. It's like an intro to proofs. Tomorrow we're doing like real geometry proofs. Let's go to substitution. So substitution is a little weird. Substitution we've been doing since basically the first day of school. When you find X, you solve for X, and then you take X and you substitute it back in to actually solve an equation. So substitution, what we're going to say is if, what did I say? A equals B, then A may be replaced by B because you're substituting it in. There are two down below that represent substitution property. Do you think you know one of them? What did you say, 13? 13 is not substitution.
5. No, never mind. No.
Nope.
It's 7.
Nope.
8. 6.
I'm 11.
1. No, 2.
No.
Roll.
Okay, take a second. Take a second.
4.
Take a second. Look at your options. You're thinking about it's substituting it into an equation.
5.
No.
That's what I said. 3. Oh, I know it.
No.
Carter, you
32.
I think we said all the.
It's not 5.
This.
Okay, I'm going to tell you which one it is.
It's 7. It's 7.
It's number 12. Oh, I didn't hear you because everybody's saying a bunch of different numbers. Says given 3x squared plus 1, if x equals 5, then 3 times 5 squared plus 1, because they're taking this and they're substituting it in. So that's substitution property. The other one that represents substitution property is technically number 8. 8 says if 10x plus w equals 41, w equals 1, then 10x plus 1 equals 41. Because they're taking it, they're plugging it in. Substitution.
Make it seriously.
Okay, well, everybody's like saying a bunch of random things, so I can't even hear what people are saying. Shh, be quiet. The next one is, we're going to kind of like work with the bottom ones first. The next one you've never seen before. This is new. This is from geometry. These 3 are technically from geometry. Reflexive property is very random. It says for any real A equals A. It equals itself. It basically repeats itself. So reflexive repeats itself. Which one repeats itself? 3.
6. Oh, that one. Will you not repeat itself?
No. So number 3 repeats itself literally identically, like literally the same thing. It's pointless. It literally repeats itself. This one is really never used, but sometimes they will throw it in. A lot of people get reflexive property and symmetric property confused with each other. This one's also a new one, so put a little star next to it. Symmetric property is what number 1 is. It's symmetric. Or symmetry. Symmetry. So if A equals B, then B equals A. It's literally just flipping symmetry. So number 1. Number 1 literally flips itself. So that is symmetric property. The other new one for geometry is transitive property. Transitive property we slightly talked about on Friday. This is basically if A equals B and B equals C, I can remove what they have in common. So they both have B in common. I can cross out B and I can say A equals C. Yep, 5. What does 5? 5 is some transitive property. What does 5 have in common that I could cross off? 2B. So 2B and 2B both are the same. So if 10A equals 2B and 2B equals C, then I can justify saying that I can remove the middleman. So that's transitive property. There's another, hold on, property.
Yeah.
7 is not transitive property.
9.
It is 9. 9 says if 2x equals 2y and 2y equals z, I can remove 2y from both sides and say 3x equals z. So 9 is transitive. Transitive. Let me make sure. There is another symmetric property that we skipped. So can anybody take a second? Symmetric is where it flips itself. 11. 11 is symmetric. So we're kind of moving through these fast. Let me make sure we didn't miss anything else. Well, because we're gonna have to fill them in anyway, so I don't want to confuse you with everything else before we. Okay, the last 4 that we haven't done are technically from Algebra 1. So the last 4 are addition property, subtraction property, multiplication property, and division property of equality. So addition property is where, or let's do division first, since we're like kind of working up. So division property is where if I say A equals B, then A divided by C also equals B divided by C. So if I'm dividing by something to both sides, does anybody see one that represents division property of equality down? Number 2. So number 2 is division property because it says if 2x equals 14, then x equals 7, because they are not showing you're dividing by 2, but you would divide by 2. So number 2 is division property. Is there any other division? No. Okay. Multiplication property is where you multiply to both sides. So if I say A equals B, then I could say A times C equals B times C. So you are multiplying by the same thing to both sides. Which one at the bottom that we have left over represents you multiplying by the same thing to both sides? Which one? Yes, 13. So 13 says if m equals -2, then 8m equals -16 because they multiplied by 8 to both sides. So this is multiplication property. And now we have 3 left. So we have the 2 options. We have addition property and we have subtraction property. So, addition is 10.
7 is subtraction.
7 is subtraction. Nope, 4 is not subtraction. So for the reason why people get tripped up on this one, because they're like, it's a minus sign. To get from the -11 to the 10, what you're not showing is technically like you're adding 1 to cross it out. So when they add 1, that's technically making -10. So it's opposite operations. So this is addition property. And then we're going to fill out the top part. And if you're like completely lost in the sauce, this is a lot. And we kind of went through that fast. You'll realize when we start doing them, like, oh, this kind of makes sense. Like, it's like a pattern. So at the top, let's fill in these last 2. If A equals B, then A plus C equals B plus C. If A equals B for subtraction, then A minus C equals B minus C. What that means is like whatever you do to one side, you also have to do to the other side. If I'm adding, then I'm adding to both sides. If I'm subtracting, then I'm subtracting to both sides. Multiplying to both sides, dividing to both sides. So this is your first day of proofs. So let's go to the next page. So proofs are basically 2 columns. Sometimes they can write it out as a paragraph. The nice thing is for geometry nowadays, you will always have a word bank. On your EOC, on your test, you will always have a word bank. It'll be drag and drop, or it'll have a little drop down box that you can choose options. You never physically have to type these in. You will always have a word bank. Today, I did not give you a word bank because it's not really geometry proofs, it's algebra proofs, so they're really simple, okay? So it says a 2-column proof. If you look at your problems, they're like 2 sides. The left side, if you look, the left side of a proof is always the statements. The right side, if you look at the right side is always like your justifications. They are your reasons you're doing something. So these are your reasons. There are 4 different things that you can use for a reason. Well, for today, what we're using is properties. So we're going to say properties. Because everything we've done today is literally properties of equality, like addition, subtraction, multiplication, division, property of equality. Shh, be quiet. The other thing you can use is theorems. So one day we're going to be doing proofs on triangles, and you're going to say like the Pythagorean theorem because it's a theorem. It's like a rule that we talk about in geometry. Postulates, which is basically another word for theorems, like segment addition postulate, angle addition postulates. We already learned those. It's just like rules in geometry. The last one is definitions. So if it's saying 2 angles add to make 90, they're complementary, then the reason why is because of the definition of complementary angles. Complementary angles add to make 90. So today is very basic. It's algebra 1. So you have a given problem. It says 4x minus 1 equals 27. We need to prove they're giving us the answer. We're proving x equals 7. So they're telling us the answer is 7. The first reason is always given because that's the problem that is given. So if you were solving this, what would you do? You would add 1. And that's how they get 28 because the problem's already solved for you. So if you want to show that you're adding 1 to both sides, you can. You don't have to. So we're going to say addition, property of equality. Because it's a property, addition property of equality from middle school. And then step 2, what do? Division property of equality. And then you would get x equals 7. So it's not showing the work, but it's doing the math. So division property of equality. And then you're done. That was easy. Okay, let's go to number 2. Number 2. From step 1, it's given a divided by -6 plus 2 equals 5. We're proving x or a equals -18. The first thing is given always and forever, no matter what. What did they do to go from step 1 to step 2? Subtraction, property of equality. We're going to shorten it in the next thing I'm going to show you right now because I'm tired of writing it as well. And then from step 2 to step 3, what did they do? They multiply. The opposite of fancy fraction, the opposite of division is multiplication. So we're going to say multiply property of equality. So we're going to shorten it to POE instead of writing out property of equality because that's annoying. Okay, why don't you take a second? Why don't you try number 3? Easy, easy. The top 2 is addition, property of equality, and then division, property of equality. So number 3, think about how you get rid of your parentheses. What property is that?
6 and 7 on the first.
Where?
Oh, on the other page that you gave me.
Oh, on the other paper?
No, it is. It's 6x plus 7.
It is about like 6.
I was like, where? There's not even a 6 and a 7 on here.
It's a friend.
Because it's so funny.
You like, who said that? Stop. Yeah, man, it was fun to say.
That's not that serious.
Mario sent me from
Yeah, because he got Mr. Predator mad. Because he kept saying 6'10".
Who's Mr. Predmore?
the one.
Oh,
Wow. Wow.
saying I'm talking to nobody. Like, I get here, and then when the bell rings at the end of the day, I'm like, okay, bye. And then I'm like, I talk to like 3 people. Those are the people that are right around me.
Oh, yeah.
That's it.
Teacher right there.
Yeah. That's it. I'm like, if you're not next to me, I'm not talking to you. Okay, so number 3. So the first thing is given. They tell me that. I'm trying to prove that x equals -2. I don't even have to do the math. They did it for me. So what is that first step from step 1 to step 2? Distributive property. They got rid of the parentheses. Distributive property. They got rid of the parentheses. From step 1 to step 2 was distributive. From step 2 to step 3, subtraction property of equality. Because you would, and if you need to show the work, if you need to like physically like write this so that way you can see like how you would solve it, you could do that. What's up? Technically, yes. But like it's technically properly called distributive property, but you're doing multiplication. And then what's the last one? Division property of equality. How do we feel? Okay, let's do a harder one. We're only gonna do like, I don't know.
Like 6, 7.
This here.
Let's do 6. 6. 6 is empty. 6 is empty. Completely. That's weird. Okay, what goes in the first?
Yeah, the X part.
3x plus 1 equals -14. What's going to be the first reason every time? Given. Where should I put x equals -5 at?
At the end.
At the end. I don't know the reason yet. So why don't you take a second? You're going to try to solve this.
Are we not doing full time?
No, we're doing all of them. But I don't want to do the easy ones for you.
Wait a second, right?
Well, those ones, yeah, but like I don't want to do the ones that are filled in.
Yeah,
for you.
why is actually second?
What would be the first step? Subtraction. So you could show the work. I'm not going to. If I minus 1 to both sides, what would I have on the other side? -15. So that is subtraction property of equality. What would be the next step? Divide. So if I divide, I'm not going to show the work, but if I divide by 3, I would get x equals what? -5, and that's division property of equality. And then that's weird. You're like, it's the same thing. Which geometry proof, theorem, reasoning, takes exactly the same thing? Reflexive property. Reflexive is pointless. It's stupid, but it's there, so we have to use it. If it repeats the same exact thing and it does not flip, if it flips, it's symmetric. If it's literally the same exact thing and you're like, well, that's stupid, that's reflexive because it repeats. Yes. Yes. Okay. So if it's silly and then you're like, what the heck, why am I repeating my same thing? That's reflexive property. Let's do another one. Let's do number 8. So I'm trying to do the hard ones. So we're going to do 8 and we're going to do 11. 8 says, given all that nonsense. So that's going to go in the first statement is the problem. I figured we'd do the fraction one because you guys hate fractions. The first reason is always going to be what? Given. The proof, the answer is always going to go in the last thing. So take a second. The first step is the hardest to this. because you have a fraction and you guys hate fractions. How would I undo the fraction? Multiply. So if I multiply both sides by 2 to get rid of the denominator, what would I be left with? Perfect. And that's multiplication, property of equality. Take a second, fill in the last 2 steps. Thanks. Yeah. So what would be the next step? Good. And what would I write over here? 5y equals 15. And that's addition, property of equality. What would be the last step? Division, property of equality. Yeah, today is easy, right? That's why I didn't give you a word bank, because today is very easy. Tomorrow you get word banks because we're going to do geometry proofs. This is obviously algebra proofs. Let's do number 11, and then you guys can work on the rest of them. So 11 is the longest, so that's why we're going to do it together. 11 says, given 14 minus 2 times x minus 8 equals 5x minus 3x minus 34, prove x equals -9. So the problem goes in the first step. X equals -9 goes in the bottom because it gave me the answer. The first thing is always given. This one's kind of long. So I have this long, crazy problem, and if this was on a scratch piece of paper, what would your first thought be to do? Distributive property. You're multiplying into the parentheses, so we're going to get rid of the parentheses using the distributive property. So I'm not distributing in the 14 stays in the front. -2x minus 16 equals 5x. What's on the other side? Nope. What the heck? Okay, this is like a -1. Maybe that's what somebody meant. There's like a -1 here. So if I distribute this in, I'm not distributing the 5x. -3x plus 34. So that's distributive property. Good. So it's literally called combine like terms or simplify. That's the only thing that you could use that we have not talked about. So the next step would be to combine like terms. You could put combine like terms or simplify. I'm going to put simplify because it's shorter. So if I simplify 14 and -16, how much is that going to make? -2. If I combine 5x and 3x, how much is that going to make? 2x. And then I bring down my plus 34. So I'm just going to say simplify. Now you could technically go like 3 different routes, 4 different routes. What do you want to move?
Keep that to one side.
So let's
Yeah.
so
No addition.
we could add 2x. Do you want to move the 2x or the number or the 2?
Two.
I'm going to use the 2. I'm going to move the 2.
Uh-huh.
You can do whatever you want though. Shh, be quiet. So if I add 2 to both sides, my 2x stays. Over here would be 36. Addition, property of equality. I don't know why I wrote that out, but whatever. And then I would have to do what? Nope.
No, the minus 2x.
I would minus 2x. So I'm not adding 2x, I'm subtracting because this is positive and I'd have to move it over here. So if I minus 2x and cross it out, how much would be over here?
Negative.
Good. -4x equals 36. And then the last step is division, property of equality. So see if you can figure out, take a minute, try number 4. Yeah, bring me a phone. Try number 4. We'll talk about the answer. I'm not going to write it all out. But we'll talk about your answer. What's up? Yeah, thanks.
We're gonna be on the second one.
Would be. I don't get to look at cycle one. I just like all the chats. I can't look at anything. I think we get another minute on number 4 and we'll talk about the answer. If you're done with 4, try number 5 and then we'll go over number 4. Because you're gonna have to do them anyways, but I'm trying to give enough people time to try. Oh. Okay, so for number 4, the first thing is given. What do they do from step 1 to step 2? I can't say subtraction and addition. Just subtraction because they minus 6 and they minus 6. So that's subtraction. From 2 to 3, what do they do? Addition because they add 17, add 17. So that's additions, property of equality. And then from 3 to 4 is division. And then they rewrite it because in algebra, you should have learned that X should really be on the left-hand side, even though it means the same thing. What is that? The metric.
Alright.
Symmetric flips it, but keeps it the same. Okay, so you have 4 problems to do. You are going to take a picture of this page and put it online when you're done. So just this page, because we did everything else together. So a picture of this goes online. So do it now. Take a picture before you go. You got 4 problems. These, because then we do the whole other one together. Yeah, we did everything else together. Yeah, I'll do that. Oh, I mean number 4.
No, number 8, I think.
Number 8, 11.
No, at the top.
Okay.